Hello, hello. We are back with Chapter 10, Probability, Lesson 8, Permutations. Now, last lesson we talked about were combinations, and now we're going to talk about permutations, and they're kind of closely related with each other. So remember, combinations, the order did not matter, but with permutations, these deal with different types of probability problems where the selection of objects, in a permutation is a selection of objects in a particular order. So for this one, a permutation is a selection of objects in a particular order. So that means for these, the order matters. Order matters. Okay, so maybe something like a password. You know, a password is something where the order matters, you know, of particular letters. Like if I had a password that was, you know, ABC and a different password that was BAC, those are two different passwords. They are different things. Where with a combination, they would be the same thing. They would represent the same thing. So let's look at a permutation example. In how many ways can Allie, Bob, and Carl stand in a line? And so what we're going to do is draw a tree diagram to find the number of permutations. So the first thing is we could have Allie in front of the line, okay? And then who would be in back of her? We have two options. We have Bob and Carl. So Allie could be first, right? And then it could be Bob or Carl. Okay, so if we go Allie, Bob, then it has to be Carl. And then if we go Allie, Carl, then the third person in line would have to be Bob. So this is the first person in line, this is the second person in line, and this is the third. Okay? So those are all the options for Allie being in front of the line. But let's go ahead and move on to Bob. Now, if Bob is in front of the line, there's two options who would be in second. It would be Allie and Carl. Carl could be in second as another alternative. But if it's Bob, Allie, if Bob's in first and Allie's in second, then that means Carl has to be in third. And if Bob's in first, Carl's in second, then Allie has to be in third. Okay, the third would be Carl being in first, and then Allie or Bob could be in second. But if Carl's in first and Allie's in second, then that means Bob must be in third. And if Carl is in first and Bob's in second, then that means that Allie must be in third place, or third in line. So these are really all of the options. So what we're going to do is we're going to write down and make a list of this tree diagram. So the first one we would have would be this one right here. Allie, Bob, Carl. So it would be Allie, Bob, Carl. Right there, okay? The next one we would have would be Allie, Carl, Bob. So that would be the next one in line. Allie, Carl, Bob. Right there, okay? Then we're gonna move over to Bob. The first one would be right here, Bob, Allie, Carl. So Bob, Allie, and then Carl. And then another alternative would be Bob, Carl, Allie. Bob, Carl, Allie. That would be right here. Bob, Carl, Allie. That would be this one. And then with Carl being in first, we would have Carl, Allie, Bob. So it would be Carl, Allie, Bob. Whoopsie daisy. Followed by Carl, Bob, Allie. So we'd write Carl, Bob, and Allie. And there we have it. There's also another way to do this that's a little bit quicker, and it's we can use multiplication. Oh, whoops, excuse me. Okay. You can use multiplication to find the number of permutations. So let's go ahead and think about this. So if we're talking about somebody first in line, how many options do we have? Well, we have 3, right? It could be Allie, Carl, or Bob. So we'd have 3. But what we need to understand is that when we have those 3 people, that one person is ultimately going to be here. We're going to have one person, right? Okay, so that's the thing that we have to kind of remember, and I'm going to put that in parentheses. So we have 3 options. It can be Allie, Bob, or Carl, right? But at the end of the day, one person is going to end up being in first. So when we go to the person that's second in line, how many choices do we have for the person that's second in line? Well, there's only 2. Because one of the original 3 is now standing in first in line. And so that means there's only 2 options for the person being in second in line. And remember, that means that once we have this, that one person is standing here. So when we get to the third person in line, how many options? Well, we started with 3, but now one person is standing in first in line, and now another person standing in second in line. So now there's only one person left. We don't know who it is, but there's only one person left to stand in third in line. So the way that we can use multiplication is just by multiplying all these numbers together. 3 times 2 times 1. 3 times 2 is 6, times 1 is 6. So that's the total number of permutations right there, 6. Boom. And we did a tree diagram so you could see 1, 2, 3, 4, 5, 6. We listed them all out, 1, 2, 3, 4, 5, 6. And we can also just use the multiplication rule, which is actually really, really nice. 3 times 2 times 1, which ends up being 6. So there are 6 permutations for 3 people standing in line. Another cool thing about this is you can actually find the probability that they will be standing in line alphabetically. I'm trying to get it all in but I don't think I'm going to be able to make it happen. Okay, and how you do that, so finding the probability that they will be standing in line alphabetically. So we have, what's the probability of alphabetical order? We need to know the favorable outcomes. Well, if we have, it's the number of alphabetical arrangements. So if we have, where did we start? Allie, Bob, and Carl. I mean, how many ways are there to have this in alphabetical order? There's really only one. Like, Allie has to be in first, Bob has to be in second, and Carl has to be in third. That is the alphabetical order. So there is only one outcome, one favorable outcome for something being in alphabetical order. So that would be a 1 on top, and then the total number of permutations, that would be on the bottom, 6. And so that's the probability that they would stand in line in alphabetical order. The thing that I forgot to tell you is that with permutations, just like combinations, one of the reasons we have it is to really figure out, when you're doing probability, to figure out what that total number of outcomes is for the probability, the total number. So you're always going to have the favorable on top, right? The favorable outcomes divided by the total number. And so to figure out what that total number of outcomes is, to determine that number, you would use permutations. And that was the same thing that was true with the combinations. It was all about figuring out that number on the bottom so that we can calculate probability. Like what we just did here. See? The total number of permutations, we found that it was 6. We did we did the tree diagram, we did the list, we did the multiplication rule. We found out it was 6. And so that is the number that's on the bottom of the probability. So we can state that the probability in alphabetical order is 1/6. Boom. All right, very cool, very cool. Okay, let's look at a different problem. Problem 6. Problem 6 says, find the number of ways that you can arrange the letters in the word math. Oh, okay. Find the number of ways you can arrange the letters in the word math. Okay, so for our first letter, okay, how many options do we have? Well, there are 4 letters, right? 1, 2, 3, 4. So that means we have 4 options. But what we have to remember is at the end of the day, 1 letter is going to be in this spot. Okay? So when we go to the next letter, how many options do we have here? Well, we started with 4, but now 1 letter is occupying this spot, which means there's only 3 letters left to choose from. So that means now 1 letter is L-E-T-T-E-R, is being occupied in this spot. So when we go to the third one, this is the first, this is the second, this is now the third. How many options do we have here? We started with 4, right? But now 1 letter's here and another letter's here, which means there's only 2 left. Okay? And then we have to realize that 1 letter is also going to be here. Okay? So then we get to the last one. And we started with 4, but 1 letter's here, and then there's another letter, and then there's a third letter here. So that means there's only 1 letter left, right? So then all we do is just multiply all these numbers together to figure out how many numbers away, find the number of ways you can arrange the letters in the word math. So 4 times 3 is 12. 12 times 2. 2 times 2 is 4. 2 times 1 is 2, is 24. So there's 24 ways. Boom, right there. All right. Well, we will see you next time. Bye-bye.